Hello everyone, myself Saurabh Maurya. I am a final student of Civil Engineering Department and my seminar topic is Control of Corrosion on Underwater Pipes. Here is the content in my PPT Introduction, Zone of Corrosion on Steel Pipe, Corrosion Protection Method, Case Studies and Conclusion. Introduction. Corrosion can be defined as the deterioration of the metal due to reaction with water and atmospheric air, or the oxidation of metal catalyzed by chemical reaction with environment. Water underwater piles. Piles are the substructure member of the building used to transfer the load from the superstructure to the ground. When a structure is built in the water, the piles are to driven in the water to underwater strength. As the piles are always inside the water, they are subjected to corrosion. Corrosion mechanism of steel in seawater. On steel piling in seawater, the more chemically active surface areas, anodes, are mechanically coupled through the piling itself to the less chemically active surface areas like cathodes, resulting flow of electricity and corrosion of anodic areas. Generally, corrosion occurs when local anodic and cathodic areas continually shift about randomly, but sometimes they do not shift position and therefore the metal suffers localized attack and pitting occurs. Here is the corrosion of material. Zone of corrosion on steel pipe. Atmospheric zone, splash zone, tidal zone, submerged zone. Now, atmospheric zone. Location above ground level. Risk factor exposure to moisture, oxygen, and pollutants. Preventive measure. Application of protective coating or paint. Splash zone. Location between high and low tide levels. Risk factor alternating wet and dry condition, exposure to salt water. Preventive measures corrosion resistance coating and cathodic protection. Tidal zone. Location below low tide level. Risk factor submersion in water, presence of oxygen, potential of microbial activity. Preventive measure coating and cathodic protection. Submerged zone. Location below low tide level. Risk factor continuous submersion, presence of dissolved oxygen and corrosive substance. Preventive measures cathodic protection. Corrosion protection method. Protective coating, cathodic protection, anode delivery system, application of FRP composite. Now, protective coating. There are three types of main protective coating. One, inorganic zinc silicate primer, high build epoxy coating, and zinc rich epoxy coat primer. Inorganic zinc silicate primers. Inorganic zinc silicate primers are type of protective coating commonly used in industrial applications, including the protection of steel structures such as sea pipe. High build epoxy coating. High build epoxy coating are commonly used to protect sea pipes, which are subjected to harsh marine environments. These coating offers several advantages, making them suitable for corrosion protection in offshore and coastal structures. Zinc-rich epoxy primer. Zinc-rich epoxy primers are coatings that contain a high concentration of zinc dust or zinc powder as a key ingredient. These primers are widely used for corrosion protection on various substrates, including steel structures such as C-pile. Now, cathodic protection. Cathodic protection is a technique used to control the corrosion of a metal surface by making it the cathodic of an electrochemical cell. Cathodic protection can be accomplished by sending a current into the structure from an external electrode and polarize the metallic surface in an electronegative direction. Now, anode delivery system. These are similar to the cathodic protection method in philosophy. These are designed on the design basis of maximum current distribution for the lowest possible cost with the most long-term reliability. Application of FRP composites. FRP is mixed with wet concrete during repairs, providing a seamless and economical solution for substructure repairs. Completely corroded sections are carefully removed and FRP-induced concrete is applied, restoring lost tensile capacity and providing lateral support to steel elements. Case study for application of FRP composites: Allen Creek Bridge. Allen Creek Bridge is located on the busy US 19 highway connecting Clearwater and Petersburg. The original bridge, built in 1950, was supported on reinforced concrete piles driven into Allen Creek. The rehabilitations of Allen Creek Bridge stand as a successful case study in the strategic application of fiber reinforced polymer composites to address the structural challenges posed by an aggressive marine environment. Two different FRP wrapping schemes were evaluated. The first scheme involved cofferdam construction, enabling the use of bidirectional FRP weight in layup under dry conditions. The second scheme utilized a pre-preg system developed by Air Logistics, offering ease of installation and efficient curing. Marine growth Allen Creek Bridge and underwater wrapping Allen Creek Bridge. Case study 2: Friendship Trail Bridge. This is the oldest of the Gandhi Boulevard Bridge crossing Tampa Bay. It was originally constructed in 1956 and was slated for demolition in 1997. Thanks to community activists, the bridge was saved, refurbished, and rehabilitated. In 1999, the bridge was reopened as a pedestrian bridge and rechristened as the Friendship Trail Bridge. FRP composites were strategically applied to reinforce and replace corroded sections, preventing the original aesthetic of the bridge. Two different FRP systems were used. One was the same pre-preg system with a water-activated resin used in the Allen Creek Bridge. The other was pipe system that was used resin that cure in water. The pre-preg system was used to wrap 4 pipes, 2 using carbon and 2 using glasses. The wet layout system from pipe required on-site saturation of the fibers. 2 piles were wrapped with fiberglass using this system. Friendship Trail Bridge underwater wrapping system. Friendship Trail Bridge. Conclusion. Though there is no absolute way to eliminate all corrosion on underwater pipe, there are some effective measures to control it. Cathodic protection is quite simple, and protective coatings are used in vast and expensive structures. The FRP composites have many advantages. Lightweight, possesses high strength and chemical resistance, and moreover an incomparable flexibility of the various ways of wrapping of FRP composite. Transverse wrapping is found to be the easiest. Thank you.